Okay, so the sign for omega and alpha all depends on its rotation direction. Counterclockwise, negative, clockwise, sorry, counterclockwise, positive, negative, clockwise, negative. Let me highlight this. It's mouthful. Okay, so here we should have alpha equals negative alpha k. All right, now let's look at the next case here. Alpha. So alpha and omega are going to different direction. Yeah, it's possible. That means this disk is slowing down on the clockwise direction. So under this case, omega, it's negative. Alpha, it's positive. Okay, we have one last situation, which is both our omega and alpha are going clockwise, counterclockwise. Under this case, our omega is positive. Our alpha is also positive. One more question here. If this is our J direction, oh, come on. Huh. This is our I and J. I don't know what's going on with here. Huh. It's annoying. Anyway, if this is our I and J, where's the direction for K? Use your finger, tell me where's the direction for K. Yes, K is pointing out from this screen. If you use your fingers, right hand fingers, wrap around the direction of counterclockwise, your thumb is pointing to the positive direction for K. So K is going out from this screen. That's a positive direction for K. So whenever you have a clockwise rotation, your thumb is pointing to the different direction, opposite direction, which is into this screen, and that's when your K is negative. Okay, those are the directions for angular acceleration and angular speed, or angular velocity, which would help you on your exam rework. I don't know why. Anyway, let's move on. Now we are officially done with kinematics. So first three chapters are particle kinematics, rigid body kinematics, and kinematics for moving reference frame. So I want you to recall what is kinematics again? What is kinematics? What we have been doing for the first 10 weeks. Holden, with masses, please. Holden, what do you think is kinematics?
Like study of motion.
Study motion. That's why we have velocity, acceleration, angular velocity, angular acceleration. Okay. And yes, that's what we have been doing. But from here, from chapter 4, so that's before chapter 4.
before chapter 4, we have kinematics. And we did kinematics on particles and rigid body. What's the difference between particles and rigid body? What's the major difference between particles and rigid body? Size, dimensions, but in terms of equations, what is something that's totally different? You think about anything? Awesome.
How many points are on the column?
Say that again?
How many points per column?
How many points? Oh. Okay. Does a particle have instant center? Does a particle have instant center? Raise your hand if you think no. Why it doesn't have instant center? It's not rigid. It didn't explain why it doesn't have an instant center. What? Dimensions. Only reference to itself. Okay, the word I want to hear is there's no rotation. Right? A rigid body can rotate. Oh, it can do pure translating. It can also rotate. But single particle, there's only movement, linear motion, but there's no rotation. Instant center is only useful when we have rotation. That's why only rigid body it's possible to have instant centers, but particle doesn't have instant center. So particles are easier to start with. So that's why we start from particle and move on to rigid body. That's why our equations are getting longer and longer, because we are adding rotation to our equation. So that's what we've been doing in before chapter 4. We learned speed, velocity, acceleration, omega, alpha. After chapter 4, we're gonna do kinetics. What is kinetics? So before chapter 4 here, we learn how things move. Okay, so what is kinetics? And here I shouldn't say after chapter 4, I should say start from chapter 4. So kinetics, it tells us why things move. So we started with to describe how things move. Now we're trying to figure out why things move. Can you give a guess why things move? Gary? What? Gravity. Yeah, gravity. What is gravity again? It's a force. Yeah. Force make things move. Forces. So that's something we're going to try to figure out in this chapter. But we have a task here. We know force, it's the reason why things move. And we learned accelerations before in chapter 1, 2, 3. Do we have anything to link those two together? How can we link forces and accelerations? Austin? Mass. Okay. Let's add a mass. Then how would you relate them? What? See that again? Multiplication, and that looks familiar. If we add an equal sign, what is this? What is this guy here? This is Newton's second law. Yes, the Newton's second law builds a link between forces and accelerations. We learned how to solve accelerations from the first 3 chapters. Start from this chapter, we can add force into our equation to build the link. But here's a more accurate equation for this. It should be sum of all the forces, because mass times acceleration. But did you notice that I have my forces and acceleration in vector notation? That tells us in this course all the forces are vectors, which means they have directions and magnitudes. So whenever you have force, you must tell me what is on the I component, what is on the J component. All right. Okay, so does that mean we're officially done with kinematics? Is that a good thing or bad? We don't have to deal with kinematics anymore. Sounds like that, right? We're doing kinetics, but here's a trick. Do you see this guy here? So we can always have acceleration in our equation. Where can you find acceleration? You're gonna have to go to your chapter 1, 2, 3 to find the equations for acceleration. Just do a quick recall. How many ways we can express acceleration in chapter 1? 3 different ways. Path coordinate system, polar coordinate system, Cartesian coordinate system, right? Great. We'll get back to there again. Yes. So start from here. We have to use those things again in our equation. So that's what I mean. Everything in this course are based on each other. And if you are feeling behind, yeah, by the way, all the grades on Moodle are up to date. So make sure you check your overall grade. If you're in F or D's, you need to put some work in order to pass this course. Okay, so in this chapter, chapter 4, we have new things like forces in our equation. And where did you learn forces? Which courses you're doing with forces a lot? Before dynamics. Which one? Physics. Yeah, physics, and what's another course you have? Statics. Okay, statics. What is that diagrams called in statics? You always have to draw free body diagrams. How many of you hate free body diagrams? Raise your hand if you hate free body diagrams. Okay, great, awesome. This is a second chance for you to learn free body diagrams, because start from now, you will need to draw free body diagram for each single problem. Yep, couldn't get away from free body diagram. All right, so next we're going to talk about the standard procedure to solve problems in this chapter. Yeah, it's a cliche method. It's called six-step approach. I don't have other names, but I think you get the drill. We have six-step approach for each chapter, each section. Same deal here. So make sure you have notes for the 6 steps, and because you're going to use that as a guideline to solve all the problems in your homework or in your exams. So here, 6. All right, so in this chapter, we're going to use 6 steps. The first step would be your favorite thing, free body diagrams. So here's the trick. You need to draw a free body diagram for each mass. If the problem gave you multiple masses, you have to draw multiple free body diagrams. Step 2, it's once you have the free body diagram, you need to set up coordinate systems for each mass. That means set up X and Y's. Step 3, Step 3 is to write out all forces in vector form. That means all your forces has to be in the form of something X, something I plus something J. Step 4 is to write all accelerations in vector form. Keep that in mind. Our acceleration could have different ways, right? You remember in chapter 1 we learned acceleration can be written in polar, path, or Cartesian. So make sure you familiar yourself with different expressions for acceleration from chapter 1. All right, step 5 is to assemble all the vector forms of forces and accelerations into Newton's second law. So write out the sum of forces equals ma. So this will give you a vector equation. Okay, you remember what we did in first 3 chapters? Whenever we have a vector equation, what do we do after? Break it down to 2 scalar equations. Yes. Same deal here. Once you have that vector equation, break it into 2 scalar equations. Okay, make a note here. This Newton's second law is for each mass. If you have multiple masses, you want to apply Newton's second law to each mass. Then if you have multiple mass, like for example, 2 blocks in your problem, you're going to have 2 Newton's second law equations for each mass. You will end up with 2 vector equations. If you break both equations down, you will end up with 4 scalar equations. Okay. Let's look at step 6. Step 6 is to add any needed equations. Okay, it's easier to say add any needed equations, but where to find those equations? If we need more equations, well, why we need more equations? In the step 5, we already have 2 scalar equations. That can, if you have 2 equations, you can solve up to 2 unknowns, right? What if you have 3 unknowns in the equation? You want to build 1 more equation. Now, where do you get this 1 more equation? You get that equation from kinematics equations. What is kinematics? That means everything you learn in from chapter 1 to 3. Here, that means it's kinematic equations. Chapter 1 to chapter 3. Okay, now we have this 6 steps approach in chapter 4. Make sure you have this as your guideline for all your problems, homework problems, exam problems. Okay, now let's do a practice to see how to apply those 6 steps. We have a car. Or maybe to simplify this, we have a block. It's sliding on a horizontal surface with the initial speed v. This block has the mass m. So the surface, between the surface and the block, there is friction. The friction coefficient is mu k. So we're given mass, speed, and mu k. We want to find out what is the acceleration. First, let's look at this situation. If we have a block moving on a surface with an initial speed, and if there's a friction, what would happen to that block? It was slowing down, and eventually we're just stop, right? So we're trying to find out what is that acceleration that caused the slowing down. Those are the only givens we know. And this is a problem we can solve by using the 6-step approach. Okay, now I want you to try your best to look at the first 2 steps. Set up your free body diagram for this problem and set up your coordinate systems. First, let's confirm we only have 1 mass, only 1 block. That means you will only need 1 free body diagram for this block. Okay, try your best to draw a free body diagram on your notes for this problem. how many forces on your free body diagram? Show me your fingers. I want to see how many forces. 3. So 4, 3. Okay. Joshua, what's the first force on your free body diagram?
I got weight.
Weight force. What's the direction for weight force?
Downward.
Going downward. Okay. Kenny, what is the second force on your free body diagram? What? See that again? Another force to the right. What would happen if you have a force to your right? Is this block slowing down or accelerating? It's slowing down. If it is slowing down, should you have a force pull this block to the right or left? Left. Okay, that's the friction force we're talking about. Okay. Kylie, what is the other force you have? Normal force. What's the direction for normal force? Going up. Okay, Sean, what's another force you? That's all you said. So 4 forces. What's the other one?
Velocity.
It's velocity of force. Okay. If it is not a force, it shouldn't be on your free body diagram. All right. Make a note here. You should only put forces in your free body diagram. No other things. So here for this problem, we have 3 forces. And you can make an kind of add a dot to show the direction for velocity and acceleration outside free body diagram as a reference for yourself. But those accelerations and velocity should not be on your free body diagram. Okay. Then step 2 is to set up your coordinate systems. Let's use y and x as our coordinate system. Okay, what is step 3? Look at your notes. What is step 3? Write all forces in vector form. Okay, now try your best to write all the forces. We only have 3 forces. Write them into a vector. Okay, I don't know what's going on here. We're active. All right, let me share again. Now we are back online. Super slow for some reason. Okay, now we're good. Friction force equals to friction coefficient times normal force. That's mu k times n. The direction of the friction force is pointing to the left, which is on the negative direction for I. So it's negative I. That's your friction force. Now we have all the forces in vector form. Step 4 is to write out acceleration in vector form. Here we only have one acceleration. That's the main acceleration caused the slowing down. So acceleration gonna be just negative a I. Why a is negative? Because this block is slowing down, so acceleration must point into the opposite direction as the speed, as the velocity. So now we have step 1 to 4. Can you try your best to assemble our Newton's second law in step 5? Step 5 is to assemble sum of forces equal to ma. Okay, try to see if you can sum all the forces into that equation equals to ma. Okay, so this is how I would do it. So I just simply go to step 3 to grab all the forces in vector form and put them into my Newton's second law equation. So on the left-hand side, we have sum of all the forces, summation of all the forces. So simply just grab all the forces. That's normal force plus the weight force plus the friction force. Now we end up with this. And the right-hand side, we have mass times acceleration in vector form. Okay. Now, can we combine all the I terms and J terms? Yeah, let's do that. To organize this, combine all the I terms. Now we have N minus mg, that's our J term, plus negative mu k N plus ma. Here I have two different ways you can do this. If you look at the first box here, I simply put everything through this, everything into the left-hand side of the equation. Then I combine all the j terms and all the I terms, and then make this equation equal to 0 because I simply moved this, the right-hand side to the left-hand side. And the second equation here, I didn't do that. I just simply organize everything on the left-hand side to get I and j, and then leave the right-hand side as just negative MAI plus 0j. Either way works, and you should able to break these two equations, either one of those equations into two scalar equations. Okay, next class, we're gonna continue this 6-step approach, but that's all for today.